So now we're going to look at a few examples of quotient manifolds, and the first one we're going to look at is what is called the real projective plane. Or real projective space more generally. So this is Rp n minus 1. Okay, so the real projective space Rp n minus 1 is the set of all directions more technically it's the set of rays which pass through the origin. In Rn. Okay, well, or if you prefer, all the set of all lines passing through the origin in Rn. So let's Rn star be Rn excluding the origin. Okay, and the idea, of course, is that you can characterize it's like the set of lines it's like passing through the origin by having some non-zero vector in Rn, and then looking at R times that vector. Right, that gives you, of course, the line which goes through the origin. Okay, so this is the Euclidean space Rn with the origin removed. Okay, and then let me just sort of remark that R n star is a particular case of the non-compact Stiefel manifold. Right. So this is the set of n by p matrices like which have full rank. So this is n by p matrices with full rank. Okay, so well, the obvious case is that it's p equals to 1 case of the non-compact Stiefel manifold. Okay, and you typically think of the real projective plane or space, right, as the following. So we think of Rp n minus 1 as being given by just Rn excluding the origin. It's like quotiented by some sort of equivalence relationship, where the equivalence relation is as follows. So what you expect basically is that you want to have an equivalence relationship which identifies, it's like points in Rn excluding the origin, it's like which generate the same line, right? So x is related to y if and only if the following is true. There exists some non-zero scaling factor, right, such that y is equal to t times x. Okay. So so then, as you might expect, then it's like when you look at a particular non-zero vector, it's like as defining a line, and you quotient it by this relationship that any 2 points it's like on that same line are related to each other. Then obviously you get the set of lines it's like which pass through the origin. Okay, so Rp again stands for real projective. And the superscript obviously is the dimension of the space. And you can define this sort of for more general spaces. You can also obviously have the complex projective planes, that's like all spaces and so on. Okay, so this is again one particular example of a quotient manifold, okay, which we'll be looking at, and there'll be another one, which is the Grossmanian syntax, which we'll also consider in a little bit.